This is Jonathan Hung from period 3 of Farrar's AP Calculus AB class, and today I will be doing problem number 3 from the FRQ section of the 2014 AP Calculus AB exam. So, problem 3 asks us, the function f is defined in the closed interval between -5 and 4. The graph of f consists of 3 segments and is shown in the figure above. Let g be the function defined by g of x is equal to the integral between -3 and x of f of t dt. So part A asks us, find g of 3. Well, since g of 3 is this integral, and we know that the integral is representative of the area beneath the curve, you can see this. So since we just simply the areas added together, we see that there's an area here, and there's an area here because it's between -3 and 3. So we're trying to find the integral between these two numbers. And we see two very apparent areas. One from -3 to 2, which is a triangle, and another from -3 and down here, -3 to 2. Which is a second triangle. So to find the area of these two triangles added up together, we just simply look at the graph. 5 units across times 4 units of height times half, plus -2, because this is a negative y value, multiplied by 1 times half. This is equal to 9. So that's our first answer. Part B asks us on what open intervals contained in -5 through 4 is the graph of g both increasing and concave down. Give a reason for your answer. So in chapter 4 we learned the first and second derivative tests, but let's find out what they actually mean first. First derivative is simply the slope of a graph, so slope of g in this case. Second derivative is the slope of the slope of g of x. Right? So, in order for, let's look at our first condition. Graph of g must be increasing, right? So that means that at g prime of x must be positive, is pos. And since we know that g prime of x is actually f of t dt, sorry, not dt, f of t, because differentiation and integration are opposite of one another, and if you do d dt of, or sorry, d dx of x minus 3 of f of t dt, you actually get f of t, because by the second fundamental theorem of calculus, this just cancels out to 1, so it's just f of t. So that means that wherever f of t is positive, g prime of x is increasing. That means that g is increasing, sorry. Whenever f of t is positive, g is increasing. So we look over here, and we see that f of t is positive from -5 to -3. From -3 to 0, and 0 to 2. So that means that we can have possibility of -5 to -3, -3 to 0, and 0 to 2. Those are our possible answers right over here. Now, look at the second condition. The second condition states that the graph is concave down. That means that the slope of g must be negative. That's how we tell if something is concave down or not. So that means we just look at the slope of this graph, which is already the derivative, the first derivative of g, to find out whether it's concave down or not. As I said before, if the slope of g has negative slopes, if the slope of g is negative, then it's concave down. If the slope of g is positive, it's concave up, or g is concave up. So we can see that there's a negative slope from here to here. There's a positive slope from here to here, and there's again a negative slope from here to here. We can therefore eliminate -3, 0, as a candidate because it has a positive slope. And a positive slope would mean that G is concave up. So we can, our final answers would just be -5 through -3 and 0 to 2. Part C asks us the function h is defined by h of x is equal to g of x over 5x. Find h prime of 3. So we'll first find the the general solution for this is h prime of x is equal to, we're using quotient rule here, right? Quotient rule, because we need to find that. So it's low d high minus low d high minus high d low. 5x times g prime of x minus g of x times 5 all over 25x squared. Now let's find out what g prime of x is. So we actually discussed before that g prime of x is merely f of t. So if we're going to do h prime of 3, it's simply going to be 5 times 3 times g prime of 3 minus g of 3 times 5 over 25 times 9. G prime of 3 is simply f of 3. So we just look on this graph and we see that f of 3 is minus 2. So this equals to 15 times minus 2 minus, what was g of 3? G of 3 we actually solved in part A, so that's 9. So minus 9 times 5 all over 25 times 9. We can do some basic simplification here to get 1, 5, 3. Simplifies to get 3, 3, 1. This equals minus 2 minus 3 over 15, which is equal to minus 5 over 15, which you can see is minus 1/3. Now, our final part is the function of p is defined by p of x is equal to fx squared minus x. Find the slope of the line tangent to the graph of p at the point where x is equal to minus 1. So, we first will find the general solution. So it is p prime of x is equal to f prime x squared minus x. And since this is actually a chain rule problem as well, we need to take the derivative of the inside of this function. So we have to do 2x minus 1. Now we actually plug in the actual solution, or the actual x value we want, which is at minus 1, to get f prime of minus 1 squared minus 1 times minus 2 minus 1. That's pretty difficult to see, I'm sorry. Which is equal to f prime of 2 times minus 3. Now what's f prime of 2? So we look over on our graph, and this is point 2. Now we do rise over run, so it's 1, 2, 3, 4. 4 units. So this is 2, 0. So it's 0 minus 4 over 2 minus 0 is equal to minus 4 over minus 2, which is equal to, I did something wrong here, I'm sorry. It's not minus 2. It's over 2 plus 2. So it's equal to minus 2. That's our slope at point 2. So we just plug in minus 2. So minus 2 times minus 3 is equal to 6, and that's our answer. So in order for more practice for this especially, you will want to review mainly chapter 4, which is applications of differentiation, because you need applications of differentiation to give a good explanation for B, and D, because you need to know chain rule, and C, because you also need to know your differentiation rule. So that's like chapter 3 and chapter 4. The only other concept you really need to know is integration, and we went over that from chapters 6 to 9, and yeah, a bit after 4 as well. So you can review those in case you need more practice, especially with these concepts like the fundamental theorem of calculus and differentiation. That's all. Good luck.